Hey, what's up, folks? Welcome back to another 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit. Joining me every week is my brother Pedro.
Good morning, everybody. Pedro's Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That is right. This is a show where we combine 3D printing and DIY electronics to make inspirational projects. Hello, everybody. It is July 17th, 2024. This is episode 447. We are hanging out in the Adafruit Discord server. If you'd like to join us throughout the show, you can drop us a comment, a meme, a GIF, a GIF. All that is good. We're hanging out in the live broadcast chat channel. And the URL for the Discord server is discord.gg/Adafruit. And we'll take a couple moments for folks to come in. And then we'll get started with the show. We have a new project, a new Learn Guide. We have some prototypes, new projects, new CAD files, models, a time lapse, and a couple of community makes. Yeah. It is peak summer. It's very hot here in our hemisphere.
Where are you at today? We just hit 93.
I'm trying to look at my weather thing behind me. It's doing the sports scores right now.
Oh.
Looks like the Patriots are away. It was like 103 yesterday, or at least it felt like. Yeah, it was pretty hot. But we're going to get a break in the next day or so.
Okay. It was nice and rainy yesterday.
Very nice. Yeah, it was rainy last weekend. All right. So shout outs to the folks in Discord. We got Duester. Hello. Vince hanging out. Hello. And Squid.jpg. Hey, folks. Thanks for joining us.
Morning.
Yeah. I will go ahead and kick off with some freebies. Adafruit.com/free. These are the deals this week. If your order is $99 or more, you're going to get a free PCB coaster with a golden Adafruit logo. If your order is $149 or more, you'll get that PCB coaster plus a free Adafruit KB2040. That's the lovely dev board with the RP2040 chip, stomach QT, and lots of GPIO pins. If your order is $199 or more, you'll get the KB2040 dev board, the PCB coaster, and free UPS ground shipping for continental US only. And if your order is $299 or more, you get the free ground shipping, the KB2040, the PCB coaster, and a free Surrogate Playground Express. All of these get automatically added to your order. And on top of that, we have a special coupon code that'll get you 10% off. Coupon code USBDoc. So type that in at your checkout and you'll get 10% off your order. And these freebie items, like I said before, they get automatically added to your cart. And that's the deals this week. I want to give a mention to a big red banner on the top of the website. We are moving. Orders will take an extra 7 to 10 business days to ship. That's right, folks. The big migration has started at the Adafruit headquarters. They're moving from Manhattan to Brooklyn in New York. So just a heads up, your orders might take a little bit longer because moving a whole factory is a logistical nightmare, but it's a big thing. And with that, their programming note tonight, we have a special edition of Show and Tell. It's going to be hosted by JP. But there will be no Ask an Engineer tonight. Instead, filling in the 8 p.m. Eastern time slot will be JP's workshop. So JP will be hosting Show and Tell and doing his show tonight.
Very cool.
Yeah. Shout out to JP. And then next week we have Melissa. And the week after that, we have me and you doing the Show and Tell. And then hopefully in August, we can have Lamar and Phil come back. They are also moving. Lots of moves this month. Let me check back into Discord. And I'll give another note. If folks are interested, there is a link to Industry City. Yeah. And it's kind of a neat area. If you want to get an idea of what the area is like, they have a nice website with all the fancy shops and stuff listing there. Check it out. Industry City. Here we come.
Restaurant and get some coffee.
Yeah,
Plant shop. It's cool.
All sorts of fun and amenities. All right, so that is the update.
Yeah, super jazzed about it.
Yeah, I think we the remote folks will probably be visiting sometime later this fall, this winter, sometime. We'll see.
Yeah, super cool.
All right, this week, Pedro, you have a new project.
Yeah, let's go ahead and jump into this week's project. This project is this super useful little USB-C dock. We talked about the older version that we've had before. It was the little micro USB dock.
Mm-hmm.
Went ahead and upgraded it with all of our new boards. They all have C now. Well, most of them have C now. So thought it was appropriate to update those. And with that, because of the new Breakout boards, specifically the socket one that we're using on, the plug version that we're using for this, makes it nice and simple to have that in the way that I made it. It lets you plug it into a breadboard or turned into a USB dock with the jumper and the header pins we're soldering onto there. So we're using the right angle headers for this to have it protrude and allow you to have it be modifiable. Something we did not do before. In the previous version, we were just soldering wires directly to it, which definitely limited the modularity of it. So this is allows you to stick it into a breadboard. And if we go ahead and take a look at the inside of this, nice little 3D printed case for this. A little bit taller than the old one, but overall a little bit smaller since you don't have all that room to work with. If I unplug this guy, you can see the socket on one side and then the plug on the top. Of course, it's a snap fit case, so I'm going to go in here and pop this guy open, take a look at the inside. We had a comment on the video, why not just use a USB cable? Well, because this can plug right into a breadboard.
Yeah, it's just a nice cleaner thing.
Yeah, so we're using the jumper cables on this, the socket jumper cable, so that can come right off like that. You can see that all the machine screws allows you to reuse this if you need to, or into breadboard. So that is the reason why we built this. So, and then again, with the USB cable, this won't plug into a breadboard. I guess do it this way you can, but this allows you to have some modularity to it. And simple USB dock that allows the USB-C boards like the Cutie Pies, the Feathers. A lot of the Feathers have the USB-C port already on there. Still waiting on the CPXs, the CPBs, the Circuit Playground Blue Fruits, and the Circuit Playground Expresses. It'll be nice when those are updated to those. What else do we need? The Clue needs to be updated for that. I think the Funhouse. Does Funhouse have?
It's got a sideways. It's a little different, but it's mainly for these type of vertical breakout boards. So here I got the Prop Maker feather, one of my favorite feathers, and I have it propped up here. Built one too. It's really easy to print. Just need a little bit of support material for those vertical tabs, but it's two-piece design, snap fits. It's got a nice Adafruit logo on the front, and I really like the super long extra USB plug. Is that the plug? Yeah, I think it's the plug.
Yep, it's a plug.
Yeah, it's super long.
I was actually thinking of how to hide how long it is, but it works out.
It's actually kind of nice. So here I have my small fidget project, and this will actually dock here. So if I want to display it upright, it actually kind of works on that too. So if you have a project that's small enough, you can even use it to dock a project. So that's kind of a neat thing as well. And because this is so elongated, it actually kind of still plugs in properly there. So I could charge it and have it kind of displayed on my desk here like that. So that's kind of cool.
Beautiful. Yeah. I didn't.
Yeah. And if you have USB-C devices like these headphones, these are Lightning, unfortunately, but let's just imagine it's USB-C.
Yeah.
This could also fit in there like that, and you kind of can dock your headphones or your USB-C device. Do you have anything like that on hand?
The phone, but again, it'll.
Oh, right, your phone's a little heavy. It's top heavy, yeah. But yeah, there you go.
Yeah, the only thing I forgot to mention or put on there was the rubber feet, which I should have made like little indentations on there too.
Oh, hey, check this out. Remember this project? This is the UV meter thing that fits on there like that. So now I can have like this light stick. Let me see if I can plug it in. So now I can have it kind of propped up instead of being laid out down. There you go.
Oh, cool.
That's kind of cool, right?
Yeah. So there you go, commenter who couldn't imagine why you need.
Yeah, that's kind of cool. It sits upright like that now. So
obviously,
not just for dev boards, for other devices that are kind of small and make sense.
I mean, the main thing too is when you are programming your board, it's not,
Yeah, it's nice to have it on your desk.
I usually have more than one board or more than one thing that could sort of short out your board.
Yeah, it's nice to have it propped up like that.
Yeah, it's out of the way.
Yep.
You have a messy desk.
That's right. Yeah, it's super easy to build. So check it out. Maybe we'll get it printed in resin and stock it in the store if it becomes popular.
The clear one would be awesome.
Yeah, and clear would be kind of cool.
Yeah, let's order up a clear one. See the
I should.
All match up.
Yeah, let's see if the tolerances fit up. Yep. So yeah, very nice.
Yeah.
Let's look at your Learn guide.
Oh, I was still looking at the wires for this. Usually, we like to use the silicone coated wires, but we're just using the PVC because they're all nice and color coded. So looks like a nice little.
That is nice. Yeah. Easily
match all the plugs. The plugs for the socket actually have six pins on there, so you have extra ones that are not available on the plug version of it. So this makes it a lot easier to match all of the pins that you need to. So they're the V-bus and the ground are on different positions or areas on the board, so that lets you sort of cross the jumper cable so you can match them up properly. And they're all nicely labeled there, so you can match those up. Yep. Accordingly. And what else can I mention about this? Customizable. You can put whatever logo you want on there. I should have gone ahead and did like the dual extrusion for the Adafruit logo on there, but pretty cool. No, I think what's cool is like the step file and the STLs are out there, so folks want to make their own modifications. They can create a multi-color version. Mm-hmm. Other thing too, there's always like privacy issues with ordering docks from overseas. So this one ensures that there's no installed in your USB dock if that is something that you're worried about. So hey, there's a feature. There you go. That's privacy. Okay. All right, let's go ahead and jump into the Learn guide for this. Pull that up. Here we go. Whee! Sorry. Got two. Let's try to. Too many cooks in the kitchen. All right, let's go ahead and look into the guide. Where's my window? Oh, I'm in full screen, so I cannot operate. Hold on, let me move that out of the way. Move that over here. Scroll around. All right. Super simple guide for this. Pretty much giving you the overview of it and all of the parts. Everything seems to be in stock. We got the plug breakout, the socket, downstream connection breakout board, of course your lovely premium socket jumper wires. These are a lifesaver. And then of course ancillaries like the USB-C cable. This is a really nice fine woven USB cable. I should have put the reversible USB-A side on it, but it's a 2 meter long one. So if you want a really long cable, definitely worth it if you want to have the reverse on it. And then the right angle breakaway pin header sockets. And then we have a link here to the M2.5 by 5 millimeter long machine screws that is being used for this build. Nice little simple array of parts. we go into the 3D printing, you'll have the links for the step file, the F3Z project files are all zipped in here into one, so you can download that and do some customization on it. Or if you just want the STLs or the design file, you want to edit that, see how this loads inside of Fusion. There we go.
Hey, it looks good.
Like. I have not looked at it this way.
Yeah, it looks good. We got 3D models of the breakouts, so folks want to download those. You can grab them from this design, and then I think later today I'm going to upload those to the GitHub repo because I haven't done that yet.
Oh, okay.
Or at least for the plug version. The socket is already up there because it's a little bit older.
Look at this literal explosion.
Yeah, explosion, all the components. Yeah.
Whoa.
Yeah, it's very nice.
So you go ahead and edit those. And if for some reason you need a vertical socket one, we do have that as well.
Yep, it was a new product last week.
Yeah. Let's see, go back here. So all of the files available there. So let me switch classes real quick. The bottom part, unfortunately, is going to need supports. So just be aware of that. I did have some issues trying to get the support material to stick to the bed, or not the bed, to the object. So you said you were using tree supports?
Yeah, I used tree supports on my part, and it worked out okay.
Okay.
I could share that if we have time, but I think I modified them a little bit, but not much. And folks have their own support settings, but this is just the ones that you used. And any changes that you did to make it fit better?
No, I just kept trying to print again.
Oh, okay.
I think it was I forget which printer actually did a better job than any of the other ones, even though they were the exact same model. So there you go. Probably I think the density, maybe jack that up a little bit. That'll work. But again, like I said, one of the other printers was able to do it flawlessly. And I think the filament too played a big role. I was trying to have these all be translucent, to have that.
Oh, yeah.
The 90s
style
with the translucent. I was trying to go that route, but none of them worked. They all looked goopy. So I don't know, the metallic-y, glittery color scheme for the video.
Yeah.
So,
yeah, they look nice.
Styles may vary based on what filament you're using.
Yep.
Jumping over to the circuit diagram, we have fritzing files for this. If you want to reuse this in other projects, you can download the fritzing file here. And then this just shows you, like I was saying earlier, the ground and the V bus are in different sides on the socket compared to the breakout. So just be aware of that. The pins that are not used on the plug compared to the socket, it's going to be the CC2 and what's the other one? V bus or S bus 2. So for whatever reason, those were left out of the plug version. So just be aware of that. I'm not sure what they actually do. I'm sure there's a
just for extra notes here, I was able to install a UF2 file of CircuitPython onto this dev board, so it does work data-wise, like data minus and data plus pin. So it works for that.
Yeah, I was able to see the files in the circuit.
Yeah, so it works.
Yep, that all works. So I wonder if it's like for, I don't know. I'll have to look at
maybe like super high voltage things, like charging a laptop, or kind of out of my element here. I'm not sure what those extra pins are for, but maybe it says in the product description. Anyway,
jumping into the assembly for this guy, the way that you solder the headers, I actually used the bottom part here as a little jig, so you could perfectly solder the right angle headers properly on there. Otherwise, you'll have to do some contortion on the way that you set it up with your little grabbers to hold your breakout in place while soldering all of the headers. So that's the only difficult part for that. And then, like as we were saying before, just match up all of the connection pins with socket jumpers. the little vertical mounts have the little split here, specifically so you can thread the wires through. So that is only the reason why you need the support materials for that. That goes through. These get mounted down with the machine screws. Then after that, then you can mount the USB-C plug breakout. Super easy. And then as you're inserting it back in, you just want to gently fold the wires into place so that they fit inside of the cover case. You'll align the cutout to the socket and the plug, and then just one side at a time to have it clip back into place. That's it.
Yep.
Nice little assembly for that. And that's pretty much it. Find yourself a USB cable that's long enough so you can either charge or reprogram your board.
Yeah.
And that is it. Oh,
easy peasy.
Get some rubbery feet.
Yeah, rubbery feet. I should put some on
there.
Yeah.
Slide around.
Yep.
That's pretty much it. Nice little simple USB dock, modifiable, editable, breadboardable if you ever needed to.
Yeah, multi-purpose USB-C dock.
Yes. Yeah, that is it. Been wanting to work on this one for a while. I forget what the took a while to get the USB plug. I think Lamar was trying to find one where the little feet went through the breakout, so it was nice and strong. So
yeah, it's very mechanically sturdy.
That's what it was. Yes.
Yep.
So, hey, finally we got some strong.
Yeah, they're super nice.
Plugs. And that is it. It is now live. You can grab all the files needed for that.
Yeah, everything's in stock. If you want 10% off your order, you can use our discount code USB doc.
Woo.
All one word.
Hey.
Yeah.
Cool.
All right, checking in here in Discord. Folks are just hanging out. All right. No questions. Let us know if you have any questions. And that's this week's new project.
Yay.
All right.
All right. Go ahead and jump into this week's. What are we prototyping?
Yeah. All right. This week we're prototyping. We got a working demo. Let me queue up my screen here. Doop-a-doop. All right. So this is a collab project with Liz Clark. She put together some Bluetooth code. This is a CNC Rotary Encoder here at the bottom. Here we have the Ortho Snap-Part NeoKey Switches. It's got a 3x4 configuration. The feather is right here with the USB port, on and off switch. It's going to be portable. I'm grabbing the cable here because I got to plug it in. But it's a work in progress. We filed an issue for some BLE stuff. So for now, we're going to use that as a USB MacroPad. So I have this plugged in, and I'm going to bring up my Octoprint screen here. So here I have Octoprint, and what I'm going to do is these three keys will actually change the state of the rotary encoder. So this first key here that's red, this is controlling the X axis. So if I move this over, you can see the printer is moving on the X axis. I switch it over to the Y axis. Now the rotary encoder is doing the up and down arrow keys, which is controlling the bed. And then the last key here switches to blue. And now I'm controlling the Z axis by going up and down. So this is Octoprint's interface. This is a built-in thing that's part of the webcam. If you click over here, it says keyboard controls active, and it gives you an idea of what the various keys will do. So you can do home key to home the X and Y. You can home the Z with the end key, and you can use the 1, 2, 3, and 4 number keys to change the step size. The step size is how much of a step is going to move depending on if you want to move the X or the Y or the Z. So you can go by 10 millimeters, 1 millimeter, 0.1 millimeters, and 100 millimeters, depending on the letter you type in. And yeah, this is all built into Octoprint with their web interface. And that's kind of the idea. So there you can see it's still moving the Z axis. Yeah, so that's kind of the demo. It's kind of cool that you can oh god, I am
Is it digging into the bed?
it is. And well, there's that. Still a work in progress. I'm not sure why why isn't my printer hitting the Z the end stop rather, sorry. Yeah, it's weird. So I'm still gonna
founding area.
I still need to test it more, and there's also a USB keyboard shortcut plugin that I want to try out, so I can do some custom things like preheating and canceling a print.
I want to request extrusion, so you can control the extrusion of it. So when you're feeding new film in, and you want to make sure that the old filament gets flushed out.
That'll be nice. There's a motor off, which a lot of the times when I'm changing out filament, it'll lock the motor. So I'd like to be able to turn the motor on and off. It'd be really nice, right? So that's why I think it's a good idea to have like a dedicated MacroPad for your 3D printer. And that's the whole point of this. That's what these rotary encoders are for. They're for CNC machines, and that's pretty much what a 3D printer is. Yeah, so we figured this will be nice. And it's going to be Bluetooth, so it'll be wireless and portable. It's got a battery in there. Yeah, so I'll do some more testing with the various plugins, and you got your own setup there. I haven't really used the Snap-Apart Ortho, but it's really cool. It comes in a 5x6, and you snap them apart, and just be cautious of which ones you're snapping apart, so that the data lines are all in a zigzag order, so that the NeoPixels are all daisy chained correctly. But we got a learning guide on it. We have a 3D model for it, and JP and Jepler have done projects with it, so there's already some demo code that you can check out for it. But again, we're kind of waiting on some internal folks on the core CircuitPython team to take a look at our BLE connection issues. But this is, BLE is very new to the ESP32S3 dev boards. So yeah, this is a good way to kind of test that out, right?
Some teething, yeah.
Yep. And you can pick up these clear keycaps. You can get a better idea, or you can go with some of the already color-coded ones.
Actually, I think going to be the most difficult part. Which colors are you going to get? Because we have so many different types, the style and the colors of all the different keycaps, and beyond all the different keycap colors and the styles is the actual switches. So we have brown, we have blue, we have navy blue and kale and a bunch of different ones. So that'll be the hardest part on customizing it.
Yep. But because it's the Snap-Apart Ortho NeoKeys, like you said, they come out. They have sockets, so you can pop them out and switch them out if you want. You can combine them if you want different, different styles, different clickiness.
Yeah, we have the ones where you can take the actual part off and add like a little 2D printed paper to have labels on.
Oh, yeah, the relegible ones. Yeah,
legible ones. We have the ones where the laser cutouts. You can see the light go up on it.
Yep.
The resin molds, so you could build your own keycaps as well. So so many options.
That's right. Let me pull it up here on the website. Here are all the different. Just type in keycaps and you'll see all the different ones.
I was in there in the morning and I was oh my god, which colors am I gonna get? What don't I have?
Yeah. Just one note: a lot of them come in the packet 10.
Yes.
This has 12. Yeah. So we do have a few that are 12 pack.
Oh.
So just keep that. Like this one here is a 12 pack. The Cherry MX Black compatible ones. But the white ones are only 10 packs. So I don't know. Just keep aware that you'll need a total of 12, not 10. Yeah. But and then we have all these custom ones with the custom Adafruit logo, DigiKey, the GitHub. I forgot we had those.
Yeah, right. Yeah. So many.
So many.
That's why I was like, that's going to be the hardest part, figuring out what color
Yeah,
combo
what would you
want
like?
or style.
Yep.
So you can have like different key styles for like each different key command or setup.
Yep. Oh yeah, we have the molds for
Yeah.
making your old one. Yeah. Here's the really legible ones. We did that emoji keyboard, another collab project with Liz.
Mhm.
So those are cool.
Those are pretty cool.
Yeah, I think it'd be handy to actually label, because it might be hard to remember. Like, oh yeah, the bottom ones are X, Y, and Z. Pedro, you were saying you wanted to make this like your editing keypad for your iOS device.
Yeah.
That'd be kind of cool.
Yep. So I can with the last project, I forget which one it was. Where
yeah, this thing, the rotary knob.
The name of it. Yeah, the rotary knob.
Yep, it's just a knob with one click, 2 click, 3 click thing.
Yeah, that's cool and all, but after a while you forget what does what. So it's a lot more user experience wise to see the keyboard and be able to click to the function you want it to.
Yep. Yeah, pretty cool. It's very heavy. That's kind of neat if you like
and
that.
Rotary
very
too, comes in, forgot about that too. You have the chrome and you have the black one too.
So right. Yeah. Yeah. We have those.
You can edit it.
Yeah. Just type in CNC Rotary, and you'll see we have two of them in stock. Black one and the red one. They both are the same, just a different color. Yeah. And wiring these up are really nice because they have screw block kind of terminal screws in the bottom here with the embossed labeling, so it's really easy to get those.
Love it.
Yeah, here's a nice demo of it in the product page.
And the way that mounts too is really cool too.
Yeah, it's got 3
washers
built-in nuts, and I think they're M4 or something, or M3.
Yeah,
screws are already built into it. It's kind of neat. Yeah, it's very nice. Very heavy. Yeah. So that's give us some time to allow the core devs to take a look at our issues with the Bluetooth. But yeah, in the coming weeks, hopefully, we'll have this out as a learn guide. Moving on from that, we got some new parts from JLC PCB using their 3D printing service. Last week, we talked about a little snap fit mount for a Cutie Pie. This week, we have an update to it. Lamar requested to have an extra 2 sets of tabs, and they have these little grooves on them so that you can actually snap them off, which I was going to do live, but I'm not sure if I want to do that, but I don't know. I bought 3. I ordered 3 of them so that I could do that. So let me see if they snap off. Hey, look at that. Nice. It snapped off nicely. So that was the idea, is to have a little groove here so you can choose what mounting tabs you want, whether the ones in the back or the front. I snapped these off, and no dust has come off, so that's nice. Pretty clean cut because I have a groove on them. Yeah, so there's our... I sacrificed this for the show, for everybody watching, so you can see that you can snap these off. So yeah, that's been tested. I've never really made a part that was designed to snap off. So that was kind of cool. But yeah, it's the same thing. Here's the Cutie Pies on it. It fits all the Cutie Pies, the Cutie Pie RP2040, and all the various ESP32s. So there's that. So that, I think we're ready to stock this.
Nice.
And then the other thing, this was a suggestion from Brett Rubel, who's on our Adafruit.io team. This is our modular kind of case for the Cutie Pies. So you got a Cutie Pie in there, and it's a 3-part enclosure. So you have a top, you have a frame, you have a bottom. It's got 2 mounting tabs on the side, a bunch of slots for ventilation and or mounting other components like STEMMA QT sensors. And it's got this like sombrero tag for hanging. Yeah, so let me see if I can pop it open with just my nail. So it's got a nice snap fit cover here. Got that open. It's very flexible, but it's still rigid. So it feels a lot like a softer PLA almost. Well, it's made out of nylon, right? Mm-hmm. Or resin. Never mind, not nylon. But it feels like it's nylon. Here's the case part. This comes off, so it's just a frame with those tabs and the USB-C cutout. And then there's your Cutie Pie. More mounting holes here, and just these snap fit edges there. So yeah, it flexes nicely to allow the Cutie Pie to come out. just like that. So I can pop that out. There we go. It's pretty strong. It's very heat resistant. It's a lot more heat resistant than regular PLA. So this would work well, I think, in the sunlight, in the daytime and stuff. So yeah, I think
Beautiful.
I think it's ready to stock. I don't know what else to test on it.
No, I think that's good.
Yeah, we'll probably stock maybe 50 to start with, just to see if we can sell through those, and then we'll order more accordingly. The way I like to put my cutie pie in is I like to insert it at an angle at the top first, and then just kind of slightly bend the front clips back so that you can fit the other corners in there. We've done this a lot, and this is a great way to mount and secure a cutie pie form factor dev board without having to use screws. Mm-hmm. And there's some clearance there for the bottom components. There.
Yeah. And because we've done it so many times, we can tell you that don't try it the other way. I have broken the stemma port trying to mount it with the USB port first, and then the other side, the stemma port, the little plastic casing around it can break.
Right.
Pressure. But the USB side, it's a lot more stronger.
Yep. Yeah, that's a good point. And then this top is kind of, what would you call it? Symmetrical. So it doesn't matter which way it goes. It just kind of works. And yeah, that's it. It's a little bulky, but it's meant to like house other components. That's why it's a little bit bigger, a little bit thicker.
I think it's big enough for, I think it's like 4 of the 0.9 inch stemma sensors.
Yeah, you can stuff quite a bit of stemma sensors.
Oh, and on the back. I forgot about the back. So
yeah, the bottom here, yeah.
6 or more.
Yep. Yeah,
so and then you can actually stack the stemma sensors on top of each other too, if it's not
I think so,
light or something.
Yep. Yeah. So good suggestion from Brant.
Yeah.
Never had it printed in this SLA resin, so it's nice to see that it worked out. The one takeaway from a design standpoint is that there's like 0 clearance between the mating surfaces. Normally when you're doing PLA prints, you want to have like an offset of like 0.1 or 0.2. Depending on your filament. This one has like 0 clearance, so it fits out really well. And I learned that when we were doing the enclosures for these things. This one's still on order. Hopefully we'll have these in the store within the coming days or weeks. This is the NeoKey. I'm sorry, the Pixel Trinky. Yeah. And these are still selling. We have like 10 in stock.
No, I think we have 6 left.
Oh, really? Okay.
Yeah,
well, these are the TRRS Trinkies, and these were the first enclosures that we have stocked. Little Adafruit logo. Awesome. Very nice. So that's our update. Cool stuff. We'll be working on some more. We're actually going to try out some clear resin for our upcoming cases, so that you can get them in clear. Mm-hmm. But we like the white because they diffuse the NeoPixels pretty nice.
Yeah, put an order in for the dock. Yeah. See it in...
Yeah, I'll do the dock. Well, I need to update it because it like I said, it won't snap.
Yeah.
If you have an offset, which I'm pretty sure you do.
Yeah, it's like 0.2.
Yeah, you got to get rid of it. So we'll update that, then I can send it out.
Okay.
And I also have, I think, this one that I have ready to send out. So we'll see how it works.
Cool. I'll update it after lunch.
Yeah, let me know. So that is our prototype, a little bit of a shop tack. And then I have one update. We had a new part request last week. It was from Charlene. She requested a 2.8 inch cap touch TFT. So we now have that as a 3D model, and we're actually using it in a future project that we'll talk about in the coming months. But this is a really nice display. It's a 320 by 240 display, 2.1 inch size. It has a iSpy connector, micro SD card slots. Yeah, it's pretty cool. Cap touch. And it's got these nice mounting tabs. So shout out to Charlene for what good timing, because like I already had the model created for that future project that I was talking about.
I thought it was for that project.
Yeah. Yep. So that's up there. And then last week we talked about the Power Relay Featherwing. That was also a user requested part. So,
Yep. Posting the links to the CAD parts as well as the fritzing if you need any of those too. So both those links are in there.
Cool. Thank you.
Discord. Oh, actually, let me put it in the other chats as well.
Yep.
Oops. I did not post any of the links to anything yet. Sorry.
Well, that's fine. Folks can always look at the description. I have links there. All right.
Here. Oh yeah, good comment from Vince saying the black would look cool. I want to see. Do they have smoky translucent as an option?
I think maybe. I'll have to look.
Was that the other place?
Yeah, PCBWay. I think PCBWay did have. You'll remember this little AdaBot. He's in like this translucent. There's a custom color, so you can do custom colors with PCBWay. You might be able to with JLC. I'll look into it, but unfortunately, I had an accident and AdaBot lost his head. Something fell on him, unfortunately. It is resin, and it can crack on impact. There's his head. So sad. So sad. Yeah. And of course, my 3D printed AdaBot has his missing antennas because it suffered from this.
Happens. Yeah,
it happens. The
first thing to go. The antenna.
Yeah.
You need to remodel it where it's just part of his head.
Right. Yep. Well, anyway, that's the update there. I think we're ready for a time lapse.
Yeah.
Let's see your time lapse.
This week's Timelapse Tuesday is this super addictive, fidgety, what is it? Spiral cone.
Spiral cone. I wish there's a name for it, but I'm seeing a lot of different versions of this type of effect where it's these two interlocking pieces that feature like a swirling shape, and they kind of pass through each other. So it gives it this kind of mesmerizing optical illusion where it kind of looks like they're passing through each other just because of the nature of the geometry where they're twisting, and they have the perfect haunches to slide between each other. It's kind of cool. I'm seeing a lot of folks on the socials print various shapes of this. I saw one this morning that was in the shape of an hourglass. That was really cool.
Yeah, this is super mesmerizing.
Yeah, pretty cool.
Super fidgety. I am surprised at the tolerances.
Yeah,
so well. It's like, here's the mesmerizing part of it. Whoa.
Right. Whoa. Yeah, that's cool. So let's watch the time lapse. I got it here.
Pull that up.
It's loading. There it is. So you printed it. And this design is by Zagatorz on Thingiverse.
Yeah. Excellent job on getting the tolerances correct.
Yeah.
Even with this oozingness that you see on this time lapse, it still works really good with the tolerances.
Nice. Yeah, it's that translucent filament tends to be a little bit more stringy.
Yeah, this is what I was trying to use for the docks that kept failing.
Right. Looks good. That's so cool.
Just a nice little fidgety, and it works both ways.
Yeah, it's cool that it works out.
The kids actually did that. I was like,
oh they did?
It works. Yeah.
All right. Well, here's the design on Thingiverse. Again, by designer Zagatorz. And here's some of their photos in solid, I think PLA. They also have a video.
Scale it up. Wow.
Yeah, you can scale it up.
Yeah, I was thinking I was gonna have to do some shaving on it, and like into all the grooves, and like add the real butter oil to have it, slide through easy. But no, whatever the tolerance offsets for this worked out perfect.
Yep. Kind of has some Christmas tree shape vibes.
Yeah.
Yeah. I was gonna read the description. I think it's in Spanish.
Oh.
Right?
I can't.
Se modela un pelo de tomando pequeño, pero que es posible. Anyway, I think it was made in Fusion 360. Yeah. Reading Spanish is a little bit hard for me, but it was printed on acrylic T Ender 3. Very nice.
Just the files. I think he has an F3D. What are the files?
Yeah, there's an F3D.
Yep.
Cono
Nice.
Spiral. Very nice. That's cool. That's great for if you want to remix it or something.
I think that's why everybody is remixing.
Yeah. Yep. Very cool. Shout out to Zagatorz. Free model on Thingiverse. Check it out. There's another one. Yeah. So I'm seeing these all over the place. Very good. Very on point.
Mm-hmm.
All right. Next up, we have 2 community makes this week. First up, we have kind of a cool remix of the Adafruit swirly mounting grid that was designed by Jeff Epler and Scott Shawcroft from Adafruit. This was put up by Jonathan on printables. And what's different about this is it has these extra shapes on the edges of the grid of the panel that allow them to be tiled. And then there's these connector pieces that kind of click them together. So they kind of snap onto the sides here. They kind of click together like a puzzle piece, basically, which is kind of cool. So it comes in several different variations. You got a 4x4, 6x6, 8x8, and then the 2 A and B connectors that snap fit into the slots. Pretty cool. I'm not sure how thick it is. It's probably like 2 millimeters or so thick, but check them out if you want to just 3D print your own. It was designed in Onshape and it's parametric, so I guess this is linked there, so you can change it. And
Jeff actually made one of the versions to be programmable on.
Yeah, they're done in OpenSCAD. Yeah.
OpenSCAD, yes.
Yep. So that was cool. I just saw it this morning and I figured I'd shout it out. So very cool.
Super cool.
And then next up, we have a make of the Lightsaber RP2040 with the prop maker feather. This was posted up by Andy on printables. They say, I went with the other pommel and emitter from the remix section, but the hilts and the rest are all really beautiful. Still work in progress. Thanks for the files.
Yay.
So shout out to the community for posting up their remixes. It's got a different emitter and a different pommel. And it looks really nice in this matte gray, kind of shiny too. Very cool.
Like he's using the retractable blade too.
Yeah, it does, doesn't it? Yeah, the little yellow piece there. Yeah. Yeah, that's what's cool about this. It's kind of modular in the sense that you can have different designs for the emitter and the pommel. Very cool. All right. After that, we have our last one for the week. Posted up by Ben on printables. It's a remix of the wearable Raspberry Pi Zero camera. And this one is redesigned to fit the Pi Sugar 3, which I think is the battery. I could be wrong. Ben says here it's a wearable case for the Raspberry Pi Zero with extra room to attach a Pi Sugar 3 battery. It is a battery. And there's a GitHub here, maybe to their code. But yeah, it's just a lot more wider or thicker, rather, so they can fit a battery in there.
Yeah,
a bigger battery. So
excellent.
Cool. Yeah, just one photo of it. But yeah, there's the original. This is when was this? When did we make this? It was a while ago, right? But it uses a Pi Zero, the Pi Camera V2, a power boost, and some little switches and whatnot. Oh yeah, it had a very small battery, a 500 milliamp battery.
That's why.
Yeah, and it was like during the trend of like wearing a camera on you, and it would take photos, and you would kind of look at your day.
Mm-hmm.
I think that's what the idea was behind this. It also has a tripod adapter on it. Yep. Cool. Shout out to Ben for posting up their remix. Very nice. People are still building these legacy projects. And that concludes Community Makes. Thanks everybody so much for posting up your makes. Love seeing those, especially during the summertime when folks are away. And we got a comment here on YouTube from Nikita saying that The swirly mounting tiles, that's the Japanese philosophy of tiling. Okay, cool.
Oh man, I missed all the YouTube comments because my chat over here for YouTube Chat Studio has not loaded.
Oh.
But I see it over here on the side.
Yep. You got it here on StreamYard. Wait, yeah, StreamYard. All right, let me check it on Discord. Comment from squid.jpg. Brilliant. Very good. All right, well, we've reached the end of the show, folks. We got about 10 minutes until noon here in the Eastern time zone.
It is lunchtime.
Yeah, it's lunchtime for us. Thank you, everybody, so much for watching. Don't forget, tonight, we got a little bit of a change in our showtime scheduling. Tonight, Show and Tell starts at 7:30 p.m. Eastern Time. Special guest host, John Park. And then in place of Ask an Engineer time slot, 8 p.m. Eastern Time, it's going to be JP's workshop. So, JP all night. So, stick around.
Well, afternoon for him.
Yeah, he's in the Pacific time. Yep. Next week, similar kind of thing. We'll have Maker Melissa will be hosting the show and tell next week. And then I think JP will also be doing his workshop at 8 p.m. Eastern Time next week. Ooh. One last question. QuinMan16 on YouTube is asking if we're in the same house. Not anymore. We used to. I'm up here in Massachusetts. Pedro's down in South Florida. Same time zone, but about 1,000 miles apart. And
Central Florida.
Yeah, you're right. Sorry, Central Florida. We used to be in South Florida. It's pretty south to me, my brother. It's like I'm way up here. I'm close to Canada. Any hoodle. Thanks everybody so much for watching. One last thing. Support the show. Support your maker habits. We got a 10% off discount code if you want to pick anything up. Use coupon code USBDoc. And please allow our shipping team 7 to 10 business days to get the stuff out because they're moving and it's a big ordeal.
Where's my stuff?
Okay, come on. All right, folks. We'll see you next week. And we hope to see you tonight on Show and Tell. Until then, remember to make. Bye, everybody.